Hi guys, I'm the Stephen B and we're back for more of quadratic equations. Let's go. So we're going to talk about the sum and product of the roots of quadratic equations. First, the nature of the roots. So again, our standard form ax squared plus bx plus c is equal to 0. So from the quadratic formula, we can have the roots. So our quadratic formula, but one is positive and the other one is negative. So we can get here the discriminant. Our formula for discriminant is d is equals to b squared minus 4ac. The discriminant provides the information about the nature of the roots of the quadratic equation. So in the nature of the roots, if a, b, and c are real numbers and d is equals to b squared minus 4ac, then the roots of the quadratic equations are when d is greater than 0, it is real and unequal. If d is a perfect square, it is rational. If d is not a perfect square, it is irrational and it happens when it's real and unequal. When d is equal to 0, it is real and equal. And when d is less than 0, it is imaginary and unequal. Using the conditions of the discriminant, we can find the value of k in a quadratic equation. So for example, x squared plus kx minus 3x plus k is equal to 0, where the roots are real and equal. Since it's real and equal, so it means our d will be equals to 0. First, we need to combine similar terms. So we have kx minus 3x. Since they have a similar variable, but they're not both numbers, that's why we only did x squared plus k minus 3x plus k is equal to 0. So our a is equals to 1, our b is k minus 3, and our c is k. So again, we use our discriminant formula, b squared minus 4ac. So we substitute our values from there. So k minus 3 squared plus 4 times 1 times k is equal to 0. So if we solve that, we will get k squared minus 6k plus 9 minus 4k. So we distributed the value of 4 with the 1 and the k, so we got negative 4k, and then we use FOIL for k minus 3 squared. So with that, we multiply the first, then multiply the outside terms, then the inside, and then the last term. So again, we got k squared minus 6k plus 9 minus 4k is equal to 0. So first we add similar terms. So negative 6k minus 4k. So both negative, it's going to stay as negative, and then we add 6 and 4. It's going to be 10k. That's why we got k squared minus 10k plus 9. So if we get the factors of that, we will get k minus 9 and k minus 1 is equals to 0. So again, we use zero factor property. You can see that in our first video about quadratic equations. Make sure to watch it. So we get k minus 9 is equals to 0, or k minus 1 is equals to 0. So we transpose negative 9, we transpose negative 1. That's why we got k is equals to 9, or k is equals to 0. So again, finding the sum product of roots, we need to remember standard form ax squared plus bx plus c is equal to 0. Sum and product of roots. So the sum of the roots is equals to negative b over a, our formula for that. And formula for the product of roots is c over a. So example, x squared plus 3x minus 5 equals to 0. So first we get our A, B, and C. Our A is equals to 1, our B is 3, and our C is negative 5. So for sum of roots, our formula again, negative B over A. So our B is 3, but since it's negative 3 divided by 1, so if we get that, we will get negative 3. And for the product of the roots, we have formula C over A. So our C is negative 5 and our A is 1. So we will get negative 5. Note that for a quadratic equation in the form x squared plus bx plus c, the sum of roots is negative b, and product of the roots is c. Next is writing a quadratic equation. When roots are given, you can write a quadratic equation by equating the roots backwards. So our given is negative 6 and 1. So our solution, we equate it to x. So x is equal to negative 6 and x is equal to 1. We transpose negative 6 to the x and 1 to the x. That's why we get x plus 6 and x minus 1. Now we use FOIL method. Again, that is multiply the first terms. So our first terms are x and x. So x times x is x squared. Multiply our outside terms, which is x times negative 1, get negative x. And then the inside term, 6x. So multiply 6 times x, 6x. Then the last term, which is 6 times negative 1, that's why we got negative 6. Then the one from our outside and the inside, 6x minus x, we get positive 5x. And our quadratic equation is x squared plus 5x minus 6 is equals to 0. When the conditions are given, you can write the quadratic equation by analyzing what is. So here's our given. The roots are the reciprocal of the roots of x squared minus 6x plus 8 is equal to 0. So you're going to get the factors of that using QT. That is again from our first video. Make sure to watch it. So our factors are x minus 4 times quantity of x minus 2 is equal to 0. We use zero factor property. X minus 4 is equal to 0 and x minus 2 is equal to 0. So x is equal to 4 and x is equal to 2. Since it's the reciprocal, it's going to be 1 over our number. That's why our reciprocals are 1/2 and 1/4. Then we substitute that in our equation. So x minus 1/2 has a quantity of x minus 1/4. So if we use FOIL method, we will get x squared minus 3 over 4x plus 1 over 8. Next, we have the roots are 2 less than the roots of x plus 2 squared is equals to 9. So we can use extract square roots. So extract square root of that and extract square root of 9. So we get x plus 2 is equal to 3 since the square root of 3 of 9 is 3. And then we transpose our positive 2. That's how I get x is equals to 3 minus 2. So our x is equals to 1. But since it's 2 less than the roots, we subtract what we just found by 2. So 1 minus 2, we get x is equals to negative 1. Then we use our zero factor property. We transpose negative 1. So it's going to be x plus 1 times quantity of x plus 1. We use FOIL there again. First terms, the inside, the outside, the inside, and then the last. That's why we got x squared plus 2x plus 1. Next is solving quadratic equation problems. First, the product of two consecutive integers is 47 more than the next consecutive integer. Find the two integers. So our first integer will always be x. Since it's consecutive, it's going to be x plus 1, which will be our second, and then our next will be x plus 2. So we'll get our formula x times quantity of x plus 1, since it's the product of two consecutive integers. So it's going to be our first and second. Is means equals 47 more than the next consecutive integer. So more than means addition, and than is an interchange symbol. So if without the than, this would be 47 plus the next, which is x plus 2. But since we have the than there, we interchange those two. That's why we get x plus 2 plus 47. We keep x plus 2 plus 47. Then we add 2 and 47. That's why we get 49. And then if we transpose our x, so it's going to be positive x minus x. The x will be removed. That's why we got x squared minus 49 is equals to 0. Then we can extract the square roots here. We transpose first 49, and then we get the square roots of both. So that's why we got x is equals to 7. Then our second integer would be 8, because x, which are 7. 7 plus 1 is 8. If we substitute our values from our formula 2 minutes ago, we will get 7 times 8 is equals to 7 plus 2 plus 47. If we compute all of those, we will get 56 equals to 56, which means it is qualified. You can also use quadratic equations in solving geometry problems. So here's our first example. The base of a triangle is 4 diameters longer than its altitude, and its area is 16 diameters squared. Find the lengths of the base and altitude. So first, it's a triangle, so we draw a triangle right here, and then we put in the middle our area, which is 16 diameters squared. So our altitude will be the x, or the height. And then since our base is 4 diameters longer than its altitude, so 4 diameter longer means we add by 4, and since it's than, we first, that's why it became x plus 4. So we will use the formula for area, which is equals to base times height over 2. We substitute our values in our formula. That's why we got 16 is equals to x times x plus 4 over 2. So first we will multiply it by 2 to take out our 2 on the bottom. That's why I got 2 times 16 is equals to x squared plus 4x. So 16 times 2, we got 32 is equals to x squared plus 4x, and then we transpose 32. That's how we got our quadratic equation. X squared plus 4x minus 32 is equals to 0. So we get the factors using QT, or quadratic trinomial. We get x minus 4 and x plus 8. So again, use zero factor property. That's why I got x is equals to 4 and x is equals to negative 8. So x is equals to 4, and if we get our base, x plus 4 is equals to 8, since our altitude is 4. The altitude is 4 diameters and the base is 8 diameters. If you noticed, we had two values. Why did we use 4? Because we are solving for measurements. There are no negative measurements. That's why we used 4. So to check, we get our formula again. A is equals to base times height over 2. We substitute our values there. So again, our area is 16, our altitude is 4 times 8 over 2. So again, we multiply by 2 to take out the 2 on the bottom. So 2 times 16 and 4 times 8. And if we multiply those values, we'll get 32 is equals to 32. Here's another problem. A 15-meter ladder leans against the wall. Its bottom is 9 meters from the wall. How much will the lower end have to be pulled away from the wall so that the top of the ladder will slide down the same amount? So, first we can draw our wall, and then we draw our floor. And then we draw our ladder leaning. What did we form? We form a right triangle. So we can use the Pythagorean theorem, which is a squared plus b squared is equals to c squared. So a is our side of the wall that the ladder will slide, b is the bottom from the wall, and c is the length of the ladder. If we substitute our values here, we'll get a squared plus 9 squared is equals to 15 squared. Now if we're going to solve this, a squared plus 9 squared is equals to 15 squared. Again, a squared is still a squared. 9 squared would be 81, and 15 squared would be 225. Then we transpose 81. That's why we got a squared is equals to 225 minus 81. And then when we subtract that, we'll get 144. So we can use extracting square roots, extract both of the roots, and then we will get a is equals to 12. Then we restate our problem. The ladder should be pulled away by 12 meters so that the top of the ladder slide down the same amount. Thank you again for watching. If you like this video, please like and subscribe. And make sure to watch part 1 to learn more about quadratic equations. Bye! So we distribute our x there. So we got x squared plus x. And then x we